We are going to talk about data, measurement of central tendency. Now, there are different ways of actually measuring this. Okay, let me just do this. Data can be described numerically by various statistics or statistical measure. These statistical measures are often grouped into three categories: measure of central tendency, which is what we are going to talk about now; measure of position, that will come later; and measure of dispersion. Now, measure of central tendency. This is how to measure it. As in, there are three main common measure of central tendency, which is the arithmetic mean, usually called the average or simply the mean, then the median and the mode. I'm sure you are familiar with what I'm talking about right now, but I'll still do my job and I will explain this. Now, to calculate the mean, this is how to do this. The sum over the number, that's the formula. The mean is the formula for the mean. Sum of data over numbers of data. So that's the formula. So that's what we're going to use here. So let's say this example is given. For the five numbers 6, 4, 7, 10, and 4, the mean is, you have to calculate it. Just add this data up, sum of the data. This is what you see here: 6 plus 4 plus 7 plus 10 plus 4 over the total number. Just count it: 1, 2, 3, 4, 5. So 5 divided by 5, that's the number of data. So 5. So when you do that, you're going to have this answer: 6.2. That is the mean. You understand? Now there's another type of mean: weighted mean. Weighted mean, it means that in the data, in the distribution, you can have more than one number that occurs. Like, you can have a number or a data appear more than once. For example, this example I did now, every number does, like, is there, but there's no repetition of any number. So this one is not weighted, but this one is weighted because this other one is weighted because we have 4 repeated is represented 2 times, 7 many times, 8 2 times, and stuff like that. So this is how to do it. Calculate for it's still the same formula: sum of data over the number of data. Now, sum of the data in this sense means like you are going to add everything together. Still the same way, but just for you to save your, probably your calculation, you have all the data that are here 2. So this is 2 multiplied by 1 because it appears once, plus 4 times 2 because it appears 2 times, 1 2, in 5 here times 1 because it appears once, 7 times 6 because 7 appears 6 times, 8 appears 2 times, so 8 times 2, plus 9 appears 4 times, so 9 times 4. So all over. Then the number of occurrence, you count this number now, you have 16. All the number 1 2 3 is 16. So another way to do that, just bring out the number of times they occurred, like 1 2 1 6 2 4. You add them together, you have 16. So, or you can just simply count the number one by one, you have your 16. So by the time you do this calculation, you multiply and you add, you're going to get your this 109 divided by 69. This is good. You're going to get this answer. So that is the weighted mean. Now, to calculate for the median, there's something I want to explain to you here. When we are talking about the distribution of the data, here for the mean, you might not need to arrange it, but for the median, you need to arrange it because we are actually looking at the middle number. That's the median. So, and that's what we did here. If they give you a distribution, you have to arrange it in their increasing order. For example, let me look at this example. The 5 number in example here listed. So look at it now. This example now said 4 is listing increasing order. So for you to calculate the median, you have to look at the increasing order. It must start from the smallest to the greatest. So that's why they started 4 4 6 7 10. So for you to calculate the median, you just need to count 1 2 3 4 5. So there are 5 data. So for you to get the middle number, you have to count 1 2 1 2. So 6 is in the middle. So 6 will be the median. So that's all. That's all about that. And that's what they did here. So 1 2 3. So this 3 is the median. 1, 2. So 6 is the median now. So the position 3 is the median, because when you pick out this median, we have two, the two sides are even. We have 2, we have 2. So 6 is the median. So it's the middle number. 6 is the middle number. So if you're supposed to calculate the mean now, so you calculate it like this. Now, mode. What is mode? Mode is the highest, the number that occur most in a distribution. That is the definition of a mode. So the number that occur most, yes, frequently. For example, if you look at this distribution now, the mode of this data will be 7, because 7 appear how many times? 6 times. Yes, so it appears 6 times and is higher than any other appearance. So that's why the answer is 7. However, they are also talking about something here that we can have. Okay, look at this distribution, this list of value. So they're talking about the fact that, look at the mode in this distribution. The mode in this distribution will be what? 1, 2, 3 appear 2 times. I mean, see, just 2 times. So it's 3. The mode is 3 because we have more than one. Sorry, every other data here appear once. Like 1 appear once, 6 appear once, 4 appear once, but 3 appear twice, 5 appear once. So 3 is the frequency, but that is the one that appear more than one, or the that appear most. Now, you're not telling us that we can have more than one mode in the distribution. For example, if you look at this data now, 3 appear 3 times, 10 appear 3 times. So they both appear 3 times. So there's no, so the highest number of appearances is 3. 3 times rather. So 3 appear 3 times, 10 appear 3. So we have 2 mode. That's 3 and 10. However, for example, if say this distribution, let's say 3 appear 4 times. But I'm just saying, and this appear 3 times. You're going to pick 3 because that one is the one that appear most. So the definition for mode is the number that appear most. But in this case, we have two different number having the same number of appearance, which is 3 and 10. So that's why we put two of them. So it's possible to have more than one mode. Now, let's move to this next topic, measures of position. Now, this measure of position, you need to take time and listen attentively, because you need to pay attention to it. Yeah, it's quite technical. Now we are just, this one is not talking about the positioning, talking about positioning and positioning. Now, let's say we have a list of value. It can be divided into quartile or percentile. Now, when we are talking about quartile, we have first quartile Q1, second quartile Q2, we have third quartile Q3. Now, the first part, which is the Q1, the Q2 is the middle number. Understand? Just like the median, the middle number. So it's just going to be 1. But Q1 is going to be a range of values, that falls within that that quarter. But this one, Q2 is going to be just one value, the middle number. Then third quarter is going to be a range of value that is more than the median. So we have two sides. The Q1, which has range of values below Q2, then Q3 has another range of value above Q2. So that's just it. When you read this text, you get to understand better. But I'm going to use this to explain to you in an example. For example, find the quartile for a list of 16 numbers. These are numbers now. And now, if you want to use quartile, please let me even say this. Don't let me limit it to this alone. If you want to solve anything on statistics, mean, median, mode, anything, please make sure that you arrange it first in ascending order or in increasing order. This is what they did so that you don't make mistake. So it started from 2 and it's progressed to 4, 5, 7, 8, and 9. So like that, arrange it that way so that you won't make any mistake. First thing, if you want to solve data question. Now the next thing they did was that, look at it. The first group, okay, let me pick out the Q2, because I told you the Q2 is always the middle number, right? So if I look at this now, let me see. If you divide it into two groups, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So What's the middle number of 16? Let's say 8. Abi, so 1, 2, 3, 4, 5, 6, 7, 8. So it's obvious as this is 8, Abi. This is the position for the middle. Then we have another 8 here. Now, there's something I did not tell you about the middle. I forgot. Let me quickly go back and tell you now. Talking about the middle, we have list of data. In this one, if we have, let me use this example I'm using to actually explain it. If I want to calculate the mean, sorry, the median of this data, I just want to use this. So since this one, the middle number here is what? 7 and 7, because if you look at the other side, it's balanced. So it means that we are going to have 7. This is a position. Look at this position, 7, and this 7, because there's no odd number, because normally when you count 8 like that, eh, you count another one. Okay, let me say 1, 2, 3, 4, 5, 6, 7, 8, Abby, and there are 16. That's the half of 16. So we start another 8. 1, 2, 3, 4, 5, 6, 7. So that is balanced. So that means the middle number is 7 and 7. For example, if I counted like the previous example I did now the other time, it was easy for me to get the median because I just calculated see, I just look for 1, 2, 3, 4, 5. So 5. So that means I count 2, 1, 2, balance. So it's easy for me to pick 6 as the middle number. However, if there's another number here, let's say 11, the middle number will not be 6 again. The middle number will not be 6 plus 7 divided by 2 if it is balanced. But in this case, it is not balanced. So it's easy for me to pick out 6. Let's use that here too. For the quota, for the Q2, which is the median, the middle number, 7 will be 8. If you count 7 2, so these 2 7 are in the middle. So all I need to do is just find the average of the middle numbers, 7 and 3. Sorry, 7 and 7. So 7 plus 7 is 14 divided by 2 is going to give me 7. So that's why we have 7 here. We have to be very careful, please. What we are talking about is the middle number. You understand? So if it's only when you do this that you are going to get to understand. For example, if this digit is not 16 digit and data, if it's 15 instead, let's say 15, so 7 will be the answer, just this 7, because the two sides will be balanced. I'm going to have 7 at one side, 7 at the other side. So but this one is 16, so it is even number. So please take note of that. So let me just give you this analogy that okay, if you have in a distribution, if you have an even number of datas, the middle number, you're going to have two middle numbers, so you have to look for the average. Or if it's an odd number, you're just going to pick the middle number. So that's just the logic here. Now, so that's Q2. Q2 equals to 7. Now, let's come back to the quartile explanation. Now, Q2 is the same thing as median or middle number. So 7 now, when we look for the average divided by 2. Now, to find the other quartile, you can take each of the two smaller groups and find its median. Now, this is how technical it is. No, we divide this one into two groups, right? And the first side, the first side is supposed to be 7 numbers. So no. You have the two groups. For the first quartile, that's the set of number below Q2 and set of number above Q2. Now, if you look at it now, smaller group and take the median now. If I take the remaining group, for example, 1, 2, 3, 4, 5, 6, 7, 8. I think I have a better way of explaining this. Okay, now let me just go back. 1, 2, 3, 4, 5, 6, 7. Right? Okay, this is the first group. Let me stress myself. This is the first group. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. You have 16 divided into 2, right? 16. So the first is group. This is what we have. So it means that we are going to look for the median of these two. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8. So the median number will be around there, 5 and 7. So 1, 2, 3, 4. 1, 2, 3, 4. So to the middle. So 5 and 7 is in the middle. So you add it together divided by 2. You are going to get the median. I will continue with this explanation in the next video. Please just take note.